for the lesson 210 Ready, Set, Go. The ready portion is looking at a function where we have a falling object. It rises and then it falls. So we have this set up and we have the three different forms which we can use. Now the next four questions are all about which is better and why. So for number one, the most useful way to find out how many seconds it would take for the ball to hit the water means that we're trying to figure out when the golf ball will be 0 feet off the ground. Okay, so it's driving the ball off the cliff into the lake. So if I want to try to find out when it's going to hit the ground, I'm looking for an x-intercept. So if that's the case, I want to be able to use factored form. The reason why, I'll leave that up to you. For number two, the maximum height of the ball. Keep in mind, we've got a cliff here, and we're going into a lake. Yay, water. Water, water, water. Definitely looks like water. And we've got a golfer here, and that golfer is swinging a golf club, and there's a ball, and then, so the golfer swings and goes choo into the lake. Or the ball does, not the golfer. The maximum height of the ball would be right here, or thereabout. And if you're looking at this, yes, you're right. Using vertex form would be the most effective way to measure what the maximum height of a golf ball would be. Now, if we wanted to know the height of the ball in exactly 3.5 seconds, which one would help the most to find the answer? For me, now this, you can justify whichever one you want. For me, I believe that standard form would be the most efficient because I can plug it in, multiply, and call it good. Now you may think factored form would be easier. That's fine. You may think vertex form is easier. That's fine. The biggest reason is, or the biggest thing about it is why. Looking for that why. For number four, you want to know the height of the cliff above the lake. Which expression would you use? So again, we have this height, this cliff. Now I drew a very short cliff, but we've got this cliff that is up here. And we want to figure out what is happening at that point. So again, you can justify this however you want. For me, I'm going to say that it would probably be easiest to use standard form to determine the height of the cliff above the lake based on the fact that I know that I've got my vertex, or my axis of symmetry based on my vertex here. So I have what I need there. I can then talk about distance going from there to there. Once I know the x coordinate, I plug that in. It will tell me the y coordinate, which tells me how far off the ground it would be. I know that it's rather complex, but that's how I would do it. So moving on. For the set portion, you're given one piece of information and you're being asked to complete the rest. So what I'd like to do is first put factored form into standard form then into vertex form. We can go from there. So to get factored form into standard form, we would multiply. So we would have x squared minus 3x plus 5x minus 15. And because I love me some simplification, we're going to combine the like terms in the middle, the negative 3x and the positive 5x. That would give me 2x and minus 15. Then from there, I need vertex form. Vertex form, I'll take half of my middle term, and when I square it, I end up with 1. The trouble is I need negative 15. So I would end up with x plus 1, and we should have a y equals out here also. X plus 1 and minus 16. So then what that means, what that tells us, is that we have a vertex of negative 1, comma, negative 16. Well, I know that my two x-intercepts are at 3 and 1, 2, 3, 4, 5. I know that my y-intercept is at negative 15. 1, 2, 3, 4. Which would be all the way down here. And I would have my vertex down here. Whoa-wee. And it would look like that. Okay. So if I want my vertex, I would have negative 1, comma, negative 16. And sure, why not? Let's go with negative 2 would get me negative 15. 0 would get me negative 15. Negative 5 would get me 0. And 3 would get me 0. And this is all based on the information that I have with my work. As for the show first differences and second differences, because I haven't gone up sequentially, it's going to be hard to do that. So instead, I'm just going to focus on using the information that I have available to me to be able to answer those questions. For number 6, we have our vertex form. Awesome. We need to get it into standard and factored form. So to do that, I'll rewrite this a little bit. So y equals negative 3 times x minus 1 times x minus 1 plus 3. Now it's going to get a little bit messy here because we need to do some work in order to make it happen. X minus 1 times x minus 1 would end up getting me x squared minus 2x plus 1, and then the plus 3 on the outside. When I distribute it in, the negative 3, when I distribute that in, I would get y equals negative 3x squared plus 6x minus 3 plus 3. Lots of stuff going on. That minus 3 and plus 3 is going to make a 0 pair, giving us negative 3x squared plus 6x. From there, we can take the factored form. So we have negative 3x squared plus 6x, and I need to factor out the most that I can from each of those terms. That would end up being y equals negative 3x, can get pulled out of both, to give me x minus 2. Good stuff. So then, I have everything that I need. I know my x-intercepts are 0 and positive 2. I know that my vertex is at 1 comma negative 3. Or sorry, not negative 3. Whoopsie. Positive 3. I know that my y-intercept is also at 0 based on standard form. So from there, I know that I have a graph that looks something like that. As for my table, I'll start with my vertex 1 comma 3, 0 0, 2 0. Then I just need to come up with one more on each side. Well, negative 1 and positive 1. When I plug negative 1 into any of those equations, I would get negative 9, which means that a positive 1 should also get me a negative 9. Because of that axis of symmetry, seeing the same thing on the left as I do on the right. For number 7, I have standard form. I need to get vertex form and factored form. The one thing that I will encourage you to do is to make sure that that x squared is by itself. So we pull out a negative, factor out a negative. Make it a little bit easier for us to see there. Then once I have that, I would have my vertex form. So I'll take half of negative 10. Negative. Half of negative 10 is negative 5. And look at that. Negative 5 squared does get me a positive 25. So there's my vertex form. And the factored form would be exactly what you see there. We've got y equals negative x minus 5 times x minus 5. Or x minus 5 squared. So the only x-intercept that we have is 1, 2, 3, 4, 5. And we know that it's pointing down because of that negative down in the base there. We know that our vertex is at 5 comma 0. So we can say that it's going to look like that. Going off of what I know, vertex 5 comma 0, and from there negative 4, negative 3, not negative 4, negative 3. Too many things going on. 4, then 3, so 6, then 7. Just go one to the left and the right. So 3 minus 5 squared, negative 2 is 4, so negative 4. 4 minus 5 squared is 1, so negative 1. 6 minus 5 squared is 1, so negative 1. And 7 minus 5 squared is 4, so negative 4. And if you're wondering, where did I get that? I took this and plugged it into vertex form. It was easy for me to be able to combine what's inside the parentheses and square it. For number 8, now you're given the graph, and you need to try to figure out how you can build based on what you see. Well, I know that I've got some information here because I have my two x-intercepts right at that point. And the point to the right is negative 2 comma 0. The point to the left is negative 3 comma 0. So I know that my factored form is going to be, at the minimum here, negative 3 0 and negative 2 0. However, when when I'm setting this up as my factors, you need to remember that we're plugging it in as the value that's going to make the inside of that parentheses 0. So when I take that -2 and plug it in, it gives me 0. When I take that -3 and plug it in, it gives me 0. Okay. So at this point, it might be helpful now to create some points, and I can start to build some of those points on the graph. Okay. We can see here that we have -3, 0, and -2, 0. That helps. I need to figure out what's happening at this -1. I should get a +2. So if I plug this in, -1 plus 3, -1 plus 2, so that's 2 times 1, which tells me that there is no vertical stretch. If I plug it in and it gets me what I'm looking for there is no vertical stretch. So I know that I have -1, +2. It'll also give me -4, +2. Now, the last part here is the vertex. Being able to see this and understand what's happening. The vertex is going to be halfway in the middle of my x-intercepts. Well, in between -2 and -3 is -2.5. So plugging that in, -2.5 plus 3, -2.5 plus 2 would give me positive 0.5 times a -0.5. And if you take 0.5 times -0.5, you would end up with -0.25. So writing this in vertex form, we know that we don't have a vertical stretch of anything other than 1. So x minus my h, and keep in mind my h is going to be along that axis of symmetry. Squared plus k, and the k said is -0.25. To get this into standard form, go here. To get this into standard form, I would encourage you, rather than dealing with the decimals, I would encourage you to mess with the factored form and multiply it out. X plus 3 times x plus 2 would get me x squared plus 3x plus 2x plus 6. So my standard form would be y equals x squared plus 5x plus 6. There's a lot going on, especially with the vertex form, especially because it doesn't give us a nice clean integer value. But hopefully this helps in being able to see it. And again, graph these out if you need to. For number 9, keep in mind, skip the factored form. So you're kind of seeing like, maybe the factored form is not going to turn out very pretty. But one thing that you can do here is you can identify it's going 12 to 2, 2 to 4, 4 to -4 to -6, -6 to -4. So right here, we're going to assume that this is where the graph turns. This is where the parabola is going to change direction, which means that this is where my vertex will be. So just kind of keep that in mind as you go through it. Now to plot some points here, plot 1, 2, 2, -4, 3, -6, 4, -4. And there, 5, 2, and then it would go up 6, 12. Okay. So again, that factored form, not looking good because it's going to go through some decimal value here. So I can graph it like that. Left side's a little bit gross, but you got the point. Next up, we can work on y equals x, and we moved to the right 3. We're going to go -3 squared plus k, but our k is -6, so we'll have it there. Next, what I would encourage you to do is to see what's going on with the stretch. So what you can do is, what I would encourage you to do is to plug in one of those values. And I'm going to plug in the 5. It doesn't really matter which one you plug in. 5 minus 3 squared minus 6. And if I do that, I would get 2 squared minus 6, 4 minus 6. That doesn't give me a positive 2. So now, I would encourage you to play around with some numbers here and see how I can make that happen. Some sort of vertical stretch. So we can take 2 times 2 squared minus 6, 2 times 4, 8 minus 6, gives me 2. Cool. One case, not good enough. Let's take another one. 2 times 6 minus 3 squared minus 6. 2 times 9 minus 6, because 3 squared is 9. 18 minus 6, and that gives me 12. So what you can do, and if you do this for each one of them, you'll see it, you would end up having a vertical stretch of 2. And it should be kind of obvious that you see, look at the graph here, and you just see that something's off. Maybe it's not obvious that the vertical stretch is 2, but you know that it gets skinnier than what it normally would look like. So that would be the first indicator that, something is off. Now, to get this into standard form, you would take and you would distribute. So first I'm going to take care of this. I would end up with y equals 2 times x squared minus 6x plus 9. Distribute that 2x squared minus 12x plus 18 minus 6. So I'm just taking that 2 and distributing it all the way in. 2x squared minus 12x plus 12 would be exactly what you're looking for. And one way to check that is to look at your y-intercept. If you plug 0 into that equation, you should end up with 12. Again, a big, meaty problem. Graph it in Desmos, verify what you have, but these two equations should overlap each other. They are equivalent. For the go portion, I'm looking for how you can multiply to get the factors, okay, or factor to get the standard, multiply to get the standard form from the factors. So you're looking at being able to distribute. And maybe you're going to draw that Punnett square. You're going to say x plus 16, x minus 4, however you want to do it. Whether it's the square, whether it's distributing, you should be able to say I've got x squared, I've got minus 4x, I've got 16x, and I've got minus 64, and when I combine those, I end up with positive 12. For number 13, same process. Distribute or draw your Punnett square. Either is going to be fine. And in this case, I'll do the square just to mix things up. We've got x minus 8, x minus 8, so x squared, negative 8x, plus 64, You combine those, you should end up with negative 16. So you should be able to take care of 11 and 12, but 10 and 13 should start you in the right direction. For numbers 14 through 22, some will not factor. Let's see which ones won't. Well, 6 is kind of tricky because, especially because it says 5, we know, or negative 5, we know that we need to have the same sign and they add together to get negative. So we know that we are taking negative 2 times negative 3. X minus 2, x minus 3. And for credit, I'm looking for, can you show your work? For 15, again, same sign, different sign. Okay. So same sign, it has to be negative. So we're going to take negative 6 times negative 1, gives me a positive 6. Negative 6 plus negative 1, that looks like a 7. That looks like a negative 1. So we would have x minus 6 times x minus 1. For number 16, negative 36, which means that I'm going to have two different signs. That's the first indicator right there. Then I need to think of factors of 36 that add to get negative 5. And if you set them up, 36 times 1 is a silly one. You know it's not going to work. 18 times 2, also not going to work. 9 times 4, that's 36. Negative 9 times positive 4 gives me what we need. For number 17, we can break 63 into 9 times 7. And 9 plus 7 gives me 16. This one's a little bit more straightforward because they're both plus. For number 18, I need negative 1, which means I need a negative and a positive. The trouble is, I can't multiply any real number by another real number and get negative 3 when I add them. Okay. Just can't do it. No factors. No real number factors would be even better. Okay. When you get into some higher level stuff, we were going to talk about complex numbers, and in that case, we would have a little bit more fun. And for number 19, we would say we've got x plus and x plus. The trouble is, what can we multiply to get 2 and get 7? We would say that there are no real number factors. For number 20, two numbers that multiply to get 49 and add to get 14. We know it's going to be two positive numbers because of the 2 addition there. And 7 and 7, so 7, 7, or you could write it as x plus 7 squared. This one here, we've got x squared minus 9, but there's nothing else in the middle. So I've got to think of two numbers that multiply to get negative 9. Well, we know that has to be a positive and a negative, but add together to get 0. That's fine. Positive 3, negative 3. And 22, nothing I can multiply to get me 3 is going to add to get me 11 in the real numbers. So there are no real factors. Number 23, which one could represent the area of a square? Remember, a square has the same length on each side. Think about that and explain how you know. I'm looking for how you know it would be a square. Number 24 is a rectangle, same thing. Hopefully this helps. Reach out if you have any questions.